2024 A-Level Combined Mathematics Paper 2 Part A question number 3. This question has to do with systems of forces and F equals ma. The question says a particle P of mass m lies on a rough inclined plane whose inclination to the horizontal is 30 degrees. The particle P is connected by a light inextensible string that passes over a fixed smooth pulley at the top of the inclined plane to another particle Q of mass 4m, which is itself free to move vertically as shown in the figure. So in the figure we can see we have our inclined plane inclined at 30 degrees. We have our two particles P and Q, where P has a mass of m and Q has a mass of 4m, and they're connected by a single string, a light inextensible string that passes over a pulley that is at the top of our inclined plane like so. The question then says the part of the string on the inclined plane lies along the line of greatest slope of the plane. Now the reason they say this is so that we're not confused by the direction of the string. The string is exactly parallel to the inclined plane, and due to that we can take the direction of the string as being the same as the direction of the inclined plane, and therefore the string is also inclined at 30 degrees to the horizontal. Now after this, the question says the coefficient of friction between P and the plane is given as a half. It then says the system is released from rest with the string taut, and finally it is given that the particle P moves up the inclined plane. Now with all of this information, we are asked to obtain equation sufficient to determine the tension of the string. Now importantly here, we are not asked to determine the tension of the string. Instead, we are only asked to create equation sufficient to determine the tension of the string. Now for this, all we need to do is to consider a system, draw all the relevant forces, and then finally use that to apply F equals ma in different directions to get equation sufficient to find t. So if we have 3 unknowns in our equations, we need 3 equations in order to find t. If we have 4 unknowns, we need 4 equations, and so on. Now considering the setup, the first thing we are told is that P has mass m, and later we are told that Q has mass of 4m. So therefore, in this diagram here, the first thing I'm going to mark are the two forces of mass, which is going to be the mass m pulling down with mg here, and the mass 4m here pulling down with 4mg force over here. Now after that, the next thing they say is that the two particles are connected by an inextensible string. Now if they're connected by a string and the string is taut, then there's going to be tension in the string. So therefore, I can mark a tension T like this in the string in this direction, and I can also mark the same tension in the other side of the string on the particle Q upward like so. Now I could mark the same tension at the pulley itself, but I don't really have to since the pulley is fixed. However, if it wasn't fixed, I'd have to, and anyway, marking these two tensions is not wrong. It's not necessary, but it's also not wrong. So anyway, after that, considering the rest of the forces, since this particle P is lying on the inclined plane, there has to be a normal reaction at this point. So therefore, I can mark in the direction that is perpendicular to the inclined plane a reaction like this, and I'm going to call that reaction the reaction R. Now after this, the last part of the question says that the coefficient of friction between P and the plane is equal to half. Now here, it doesn't really say if there is a coefficient of static friction or dynamic friction, and because of that, since our particles are moving here, we have to assume there is dynamic friction. So due to that, I'm going to introduce two things. I'm first going to introduce our acceleration here, which is going to be in this direction, since our particle is accelerating up the slope, and therefore we can mark an acceleration, let's say F, up the slope here, this particle Q going downward here, and we can also, since our particle is moving against our slope, mark a friction in the opposite direction to the motion, which is going to be in this direction right here. I'm going to mark that as capital F for our friction. Now, other than this, there are actually no other forces or accelerations to be considered in our system. We have marked everything. We have a reaction force here, we have a tension here, we have downward weight here, and a friction here, and we also have tension upward here on the particle Q, and a downward force of weight due to gravity on the particle Q of 4mg. In addition to that, of course, since we're accelerating, since the particle P is moving up the inclined plane, we have to mark an acceleration F here, and the same acceleration downward here, since our particle Q is going to be falling straight downward. Now given this setup, what we can do now is to try to apply F equals ma in different directions to get different equations that we can then use in order to find our value of our tension, which is in this case the tension T. So to start off, let's try to apply F equals ma to our particle P. So considering P, we can see we could apply it easily in two different directions. We could either apply it up the inclined plane or perpendicular to the inclined plane, and we are going to be applying both of them. Considering the first one, we can apply up the inclined plane at an angle of 30 degrees by marking this angle here as 30 and then considering only the forces and accelerations in the direction up the inclined plane. Now considering that, on the left hand side of forces, we have a positive force of T pulling upward and therefore we have T here, but then you have negative force of F since it is downward and therefore it's negative upward, so we can write T minus F, but then we also have a component of mg. Now if you take a look at the force mg, we can see, since it is in this direction, we can see our two forces components are going to be in this direction, which is the negative direction, and upward like this. So due to that, I'm going to have to consider this force in this direction, which is the force component of mg down the slope. Now in this situation, our angle is 30 degrees, and because of that, since this force is downward, if I draw the relevant triangles, I can see if this is 30 degrees, then this is also 30 degrees, this angle right here is 30 degrees, and therefore the component I'm looking for is mg sine 30 degrees. So due to that, if I draw the relevant triangle, I can see what I'm looking for is an mg sine 30 in the negative direction. So due to that, the force caused by mg here is negative mg sine 30. Now for this, since we are later going to have to of course find the other component, the perpendicular component, I'm going to quickly draw the triangle relevant to finding mg's components like this. This angle is 30. I'm going to quickly mark this force here, which is mg sine 30. I'm also going to mark this component here, which is mg cosine 30, not theta 30. I made a mistake. I've also made the same mistake here, it seems. Not theta, I meant to write 30. So given this, we have our three forces, which are T, negative F, and negative mg sine 30 acting in this direction, where this direction is positive. Now given that, if you consider the acceleration here, we have particle P of mass m and an acceleration upward of F. So therefore, this must be equal to m times F, where F is the acceleration in the direction up the slope. This is going to be our equation number 1. Now similarly, we can apply F equals ma in the direction perpendicular to our slope. So for this, I'm going to draw the direction, which is going to be like this. I'm going to draw first the angle of 30 degrees of our slope, and I'm going to draw a 90-degree angle here and mark this direction. Now in that direction, I can see I have force of R, but then I also have a force in the opposite direction of mg cosine 30. The reason I drew this triangle really quickly is because I could then also quickly easily substitute mg cosine 30 as the second force. Now this mg cosine 30 is in the downward direction, and if I take the upward direction as positive, it's going to be negative. So therefore I have R minus mg cosine 30. And other than that, on particle P, there are no other forces acting in that perpendicular direction. So due to that, this is all the forces, and considering the accelerations here, since our particle is going along this slope, there is no acceleration perpendicular slope. Due to that, the right hand side is going to be 0, since we have m times 0, which is of course 0. So therefore, from this equation we get R minus mg cosine 30 equals 0, which I'm going to call equation number 2. Now, with that, we are done with all of the equations we can get for particle P. Now finally, we can consider particle Q. Now for particle Q, there is no motion at all in the horizontal direction. Due to that, we can just take the vertical direction only, and that should be sufficient. So considering the particle P here, we have considered P in this direction up the slope and P in the direction perpendicular slope, and now we're going to consider particle Q in the downward direction. Now from this, we can see we have force of 4 mg downward, but then we have T upward, which means we have negative T downward, and therefore we have 4 mg minus T, and those are all of the forces acting on our particle. Due to that, we can be done with F and move on to ma. Now for ma, the mass here is 4m. Recall that Q has a mass of 4m, and due to that, we have equals 4m times the acceleration, which in the downward direction is F, and therefore we get equals 4mf, and that's going to be equation number 3. Now at this point, if we stop for a second, we can see we have 3 equations, but within these equations we have 4 unknowns. If we consider m and g to be known, we have capital T, capital F, simple f, and capital R as 4 unknowns within these 3 equations. Due to this, at this point it is impossible to solve for the value of t, since we need a minimum of 4 equations to find the values of 4 unknowns and finally find the value of t. Now, as it turns out, the fourth equation that we need actually comes from this line right here. The line says the coefficient of friction between P and the plane is equal to half. Now, in this situation, the particle P is moving relative to the plane. We can see that since it is accelerating an acceleration of F up the plane. Now, due to this, we have to assume that our particle P is under dynamic friction. And in the question here, we are given that the coefficient of friction between P and the plane is equal to half. Again, we have to assume that the coefficient of friction that they're talking about here is the coefficient of dynamic friction. Now, with these two assumptions, as we know, whenever you have dynamic friction, F, the dynamic friction, is equal to mu d times r, where mu d is the coefficient of dynamic friction and r is the normal reaction. Now, in this case, F is equal to F and r is equal to r, but mu d has to be assumed to be equal to a half. Now, due to this, in our answer sheet, I'm going to write, since P is moving, we can assume half is coefficient of dynamic friction, and according to that, we can assume that F is equal to 1/2 r, and that is going to be our fourth equation. Now, with this, we have 4 equations 1, 2, 3, and 4 that contain 4 unknowns t, capital F, simple f, and r, and therefore at this point we should be able to use these 4 equations to solve for the value of t. With this, we are actually done with the question. Now, lastly, I would like to write a little line here. I would like to write that the above equations are sufficient. The above equations are sufficient to find tension T. And with that, we can end this question. So now finally, let's discuss the marks award for this question. So at the start of the question, even though they don't say it, taking all the forces and accelerations and marking them correctly in a diagram like this gets you 5 marks. Marking all of the forces, all of the normal reactions, all of the gravitational forces, all of the frictions, and all the accelerations gets you a total of 5 marks for marking everything correctly. Now after that, when applying F equals ma, we have 3 different applications of it: this application, and this application. All 3 of these get 5 marks. Applying it in the direction up the plane for particle P gets you 5 marks. Applying in the direction perpendicular to the plane for P gets you another 5 marks. And finally, applying it downward for Q gets you another 5 marks. Now after this, the final marks are received by considering that P is moving and assuming that half is the coefficient of dynamic friction, saying that F must be equal to 1/2 r, which is our fourth equation. Getting that equation gets you a final 5 marks. And with that, we are actually done with this question. The last sentence I've written here is optional, you don't have to write it, but if you write it, it will be made clear that these 4 equations are considered sufficient by you to be enough to find the value of t. So with that, we are done with this question. I hope you enjoyed. If you have any feedback, post them in the comments down below. If you have any questions, also post them in the comments down below. Thank you for watching, and goodbye.